This lesson is on ratios, rates, and conversions, meaning unit conversions. So a ratio is just a comparison of two numbers, and it can be written in either of these three ways. So it can be written as a fraction, it can be written using colon, or it can be written using the word to. All three of these, if you were to say them, you would say A to B. That's what you're comparing. So A and B represent numbers, and so you're comparing one number to another number. A rate is a comparison of two numbers where the two numbers have different units. So a rate is a type of ratio where the two numbers have different units. And then a unit rate is a rate, so that means a comparison of two numbers with different units, but the denominator is 1. So let's look at some examples. So the good thing with unit rates is that you can use them to compare things. So it says you're shopping for t-shirts, which store offers the better deal? So here are the three deals, and if we find the unit rate, that will tell us the cost per shirt, or the cost for one shirt, and then we can compare these three stores. And so to find a unit rate, start with the rate. So the rate here is $25 for 2 shirts. And to change that into a unit rate, remember unit rate, the denominator is 1. All we have to do is divide these. So just do 25 divided by 2. And what you get is that the unit rate is $12.50 per shirt. I didn't put the 1 here, but it's per 1 shirt. So again, a unit rate, the denominator is 1. So then we go to store B. This one's $45 for 4 shirts. So if we divide 45 by 4, 45 divided by 4, we get $11.25. So this store is $11. Excuse me, $11.25 per shirt. So far, store B is the better deal. And then store C, we've got $30 for 3 shirts. So we divide 30 by 3, and we get $10 per shirt. And so the better deal would be store C. And so unit rates make it easy to compare things. And to get a unit rate, all you do is take the rate and divide it. In a unit rate, the denominator is 1. When you have money in a rate, money should always go on top. So money on top. So let me write that down. Money on top. If there's time, time always goes on the bottom in the denominator. So money on top, time on the bottom. So let's look at another example here. All right, so now we're going to look at using conversion factors. And so a conversion factor is a ratio of two equivalent measures in different units. And for my students, these conversion factors are on page 723 in your textbook. So a conversion factor is always equal to 1. All right, so this first one says convert 330 minutes to hours. So the conversion factor between minutes and hours is 60 minutes equals 1 hour. And so the question always when you're doing unit conversions is, okay, I have this number and I have this number. Do I multiply by 60 or do I divide by 60? And so I'm going to show you a way to set it up so that it tells you whether you're multiplying or dividing. So I'm going to take the 330 minutes and I'm going to write it over 1. And then I'm going to multiply this times the conversion factor. And this conversion factor, I'm going to write one of these in the numerator and one of these in the denominator. And the way I decide which way it goes is the same units have to be diagonal from each other. So since I have minutes in the top here, these minutes need to go in the bottom. So I put the 60 minutes in the bottom, and I put the 1 hour in the top. So all I'm doing is taking this conversion factor and plugging it in here. And the way I know which way to plug it in is by making sure the same units are always diagonal. And the reason that I do that is because I want to cancel out the minutes and be left with the new units of hours. And so now if you multiply this across, you get 330 over 60, and you can see it's telling you you need to divide them. So again, this helps you determine whether you're dividing by 60 or multiplying by 60. So if you set this up with the same units diagonal from each other, it will always guide you to the right way to do it. And so if we take 330 divided by 60, we get 5.5 hours. So 330 minutes is 5.5 hours. All right, let's look at this next example. We have 5 feet 3 inches, and they want to convert that to just inches. So first of all, 5 feet 3 inches really means 5 feet plus 3 inches, right? If you measure something, it's 5 feet long and 3 inches. So it's 5 feet plus 3 inches. So we need to convert the 5 feet, excuse me, to inches, and then we'll just add the 3 inches onto that. So the conversion factor between feet and inches is 12 inches equals 1 foot. So I'm not converting the 3 inches. That's already in inches. So I'm just going to convert the 5 feet into inches. So I take the 5 feet and I put it over 1. And now I'm going to multiply it times this conversion factor. Again, same units have to be diagonal. So I have feet here. So this feet needs to go in the bottom. And the 12 inches goes in top. And so now when I multiply straight across, you can see that I'm multiplying by 12 instead of dividing by 12. So it would be 60 over 1, which equals 60 inches. And then, so that's what the 5 feet is, and now I need to add the 3 onto that. And so the final answer would be 63 inches. All right, let's look at another example. So the CN Tower in Toronto, Canada is about 1,815 feet tall. About how many meters tall is the tower? Use the fact that 1 meter is approximately equal to 3.28 feet. This means approximately equal. That means this was rounded. Excuse me. So start with my 1,815 feet. 1,815 feet. Put that over 1. And then plug in this conversion factor in here. And again, remember, the same units have to be diagonal from each other. Feet up top, so this feet needs to go in the bottom. And again, the whole point of this is now this lets me know that I'm not going to multiply by 3.28, I'm going to divide by 3.28. So you multiply straight across, you get 1,815 divided by 3.28. Let me put that in my calculator, 1815 divided by 3.28. And I got a long decimal. I'm going to round it to the nearest tenth. And so rounded to the nearest tenth, it would be 553.4 meters. All right, I got one more for you. So a student ran the 50-yard dash in 5.8 seconds. At what speed did the student run in miles per hour? Round your answer to the nearest tenth. And we're going to have to use 3 conversion factors here. So what we're converting this time is a rate. So 50 yards in 5.8 seconds. So the units I'm starting with are yards per second, and they want me to convert that into miles per hour. So I have to convert the yards into miles, so I need a conversion factor for that. The seconds need to go into hours. And I don't have a conversion factor from seconds to hours. So what I'm going to do is I'm going to do seconds to minutes, and then I'm going to do minutes to hours. That's why I need 3 conversions. Because to go from seconds to hours, I'm going to use 2 different conversions. So I like to start off with this to map out what I'm going to do, and now I'll go into the conversion part. So 50 yards in 5.8 seconds. So I'm going to write 50 yards over 5.8 seconds. And now I'm going to start multiplying by my conversion factors. So we can do the seconds to hours first. We can do that conversion, or we can do the yards to miles. It doesn't matter the order here. So let's start with the yards to miles. So here's my conversion factor. 1,760 yards equals 1 mile. So I have yards in the top, so I know these yards have to go in the bottom. So same units always have to be diagonal. So 1,760 yards over 1 mile. And so what that tells me is I'm going to be dividing by 1,760. Again, what this method helps you determine is whether you have to multiply or divide by the conversion factor. So if I use the units to guide me, it will answer that question for me. So that canceled out the yards. And so if you look at the units I have right now, I have miles per second. All right, so I got my miles. We got that. That's good. Now let's work on the seconds. So first, I'm going to take the seconds and convert them into minutes. So seconds are in the bottom, so I know these seconds have to go in the top. Same units are always diagonal. All right, what that did was cancel out my seconds. And you can see we're multiplying by 60 instead of dividing by 60. So right now I'm at miles per minute. So now I need to change the minutes into hours. So I take this conversion factor now. Minutes are in the bottom, so these minutes have to go in the top. And the 1 hour in the bottom. That canceled out by minutes. And now you can see I have miles over hours, which is what I want. I'm just going to multiply this straight across. I'm going to do 50 times 1 times 60 times 60. Let me do that. 50 times 60 times 60. And I get 180,000. And then in the denominator, I have 5.8 times 1,760. And that comes out to 10,208. Then the last piece is just to divide those. So 180,000 divided by 10,208 came out to a long decimal. Again, I'm going to round it to the nearest tenth. Actually, this one tells me to round to the nearest tenth. And so I get 17.6 miles per hour. All right, so I hope that was helpful to you. If so, give it a like and a subscribe. And please feel free to leave me a comment. Till next time.